Alright guys, welcome back to yet another episode of DSA Python series, and today we will be talking about again the linked list. Okay. Yesterday we talked about how we can dif- uh, operate or have different operations in the doubly linked list. Today we will be talking more about doubly linked list, as in how to reverse a doubly linked list, right? Okay. So let me just pull out the right. Okay. I'll just put this Excalibur also. Okay. Okay. I'll do this. Yeah. I hope this screen is visible to you. And this was my Excalibur. Yesterday we talked about this deletion. Okay, how we were able to delete it. Okay, and that was pretty fair enough to get the solution, right? Now let us talk about how you can how you can reverse a doubly linked list, right? Okay, so again we will uh, draw the linked list. Okay, we will draw two. This is it, and this is this is more, right? Now I'll just have this. Again one. All right, so let me just connect. Okay. Okay. Right. So number 7. Okay. So this is at 0 position, right? This is at 1, 2, 3. Basically, these are not the position, but when we have to traverse through the loop, we take a variable which is count, right? And wherever we have to stop, we need to make this count, which should be less than x or less than x minus 1, whatever is the condition, right? So that is what we do. Okay, whenever we traverse through the loop, right, we do this, right? Now in the current question we need to reverse a doubly linked list. Let us try. Let us read the question first before we jump directly into the solution, right? Okay. Given the head of a doubly linked list, right? Head is given. It means that this whole, we would assume head as the list which is given. Okay, or you can say doubly linked list, not list. Doubly linked list is given. Okay, so you will have this head 3, then this 4, then this 5, and all these are connected across. Okay, now the question says reverse the list and return the head of the reversed doubly linked list, right? So if this is my list 3, 4, 5, then my uh, output should be 5, 4, and 3, right? So that is what we need to do. Okay. We have another question. If we have this input 75, 122, 59, 196, this will be the output, right? What are the constraints given? We have the constraint as linked list will have the size up to 10 to the power 6. Okay, so the in the worst case scenario, my value of n should be 10 to the power 6, right? So these many elements, or I would say nodes, are there in the linked list, right? That is what I mean with the constraint. Okay. And what is the node data? Node dot data means the value of the node. That is, this is 122. Okay, so this is 75. This is 59. So these values will start from 0. Okay, so these values are not negative, right? These are either be 0 or it is positive, right? And the value does not exceed 10,000. So the value inside these nodes will not be greater than 10,000. So you won't find 11,000, 15,000, or 1 lakh, right? All those values you won't be find. You will only find the values up to 10 to the power 4, means up to 10,000, right? So you can also see that there are company tags given. So these are, this question is asked in DShaw, Adobe, and NPCI, right? DShaw, Adobe, and NPCI. Okay, so this question is very good, and you should try to grasp the concept here. Okay. No. So okay, this is doubly linked list. Okay. Now I have, let's say 7. Let's say this is 21, 26, 90, 119, right? And these are the address, so this will be none. Okay, because here we don't have anything, right? And 5 I'll just have here, and 5 I'll just have here. Okay. Okay. Now this, let's say 781, so this will be 781. Okay. 253, so this will be 253. This will be 987. These are the address. 987, so this will be 781. This is 1123. This will be 1123. This is 736. Sorry, this will be 987, right? And this will be none. Okay. Now what I want to do is, so this is 21, this is 26, this is 90, and this is 119. So my output should be 119, 26, sorry, 90, 26, and then 21. So the extreme brute force approach can be what? So my extreme brute force approach can be, if I change these elements only, that will be my extreme brute force, right? Only these elements without changing the address. Okay, so without changing address, without changing address means these links are not changed, right? I'm not changing these links, rather I'm changing only the values of the nodes, right? That is what I'm changing here. So what I can do is I can have a stack. Okay, I can have this stack. Okay, so in stack, 0. So this is my stack, right? What I'll do, I'll first start putting these tags, all the nodes here. So my first node is 21. So what I'll do, I'll just put 21 here. Okay, so what I'll do, I'll just do stack dot append these, right? These nodes. Okay, so I'll append something, right? This will be my idea. Okay, so how it will append one by one? So I have to run a while loop, right? So my while, and what will be the limit of running this while loop? What will be the last limit? Last limit should be when my, let's say my current becomes here. So current dot next should be none. That will be my last limit, right? So while current dot next is not none, right? Till then it will start appending. Okay, and after that what I'll do, so let me just write this 21, then it will append 26, then it will append 90, then it will append 119. Now after that what I'll do, how can I take out this and add somewhere? Now my 21 was the first element, okay, and 119 is the last element. Why I'm using stack? Because the stack has a property that first in, last out. This is the property of stack, right? First in and last out. So it means that first in I have done 21, लास्ट आउट में 21 होगा, जो मुझे लास्ट आउट में 21 ही चाहिए. ओके, तो और इसका कन्वर्स क्या हम लोग लिख सकते हैं? देन लास्ट इन फर्स्ट आउट. लास्ट इन कौन सा था? 119 था. अब फर्स्ट आउट मतलब यही सबसे पहले निकलेगा, राइट? एंड आई वांट दिस, यही मुझे सबसे पहले चाहिए. ओके, सो व्हाट आई विल डू, what is that function which picks out these elements from the top or stack, okay, or from here? So if I have this, then what I'll do, pop. So pop is a function where I can use this to pick out these on the top, right? So for popping out also I need to have the some loop running, right? So I'll say some while loop, it will run. Okay, and what I'll do, I'll just say E is equal to stack dot pop. Okay, stack dot pop. Okay, so this I will run. Okay, I'll do it in the code also. Okay, don't worry, I'll do it. I'm just explaining what the concept is. I'm not exactly writing the code here. I'm just explaining what I'm doing. So I'm doing what? Stack dot append. So it will just append like this, and then I'll do stack dot pop, right? I'll do stack dot pop. So this is my idea, and this is the the most brute force approach. Okay, so this will be the most brute force approach, right? So we will see the optimal approach also. Okay, what will optimal approach will do? It will try to change these signs also. Okay, it will try to change these signs. It means that we will change the addresses also. Once you reverse this, we will be changing the addresses also, right? So that is the perfect solution where you can find the reverse of the doubly linked list, right? Okay. Okay, so I'll take current. Okay, current will be some head, right? And I'll traverse the while loop. Okay, and while traversing, I will keep the val as the stack. Okay, so current dot val will be my listing. Okay, so we can also see the edge cases also, that we will discuss later. Okay, in the end, let us start some while loop. While current dot next is not none, right? So this loop will continue. So what I'll do, uh, or I can also say current is not none. So that is, so I'll just say stack dot append current, and here I will do current equal to current dot next. So it will keep going, right? Then again I'll okay. So my current will come at the last, but now what I want to do is, uh, I'll again start from head. Okay. So again my current is equal to head. It will become, and while current is not none, right? So it will just pop. So is equal to stack dot pop, right? And what I'll do, I'll put this E in that current. Okay. So my current value is head. So how do I put it? So Okay, so current. So in the end, what I'll do, I have to put this E into my temp. Okay. Uh, Temp, or I would say current. Okay. So I will just simply do current is equal to, I'll simply do current dot val is equal to E, right? And I'll do current is equal to current dot next. That's it. Okay. So what will be the time complexity? Let us try to compile. Stack. So it's saying stack is not defined. Okay. Stack is not defined. So I'll just simply assume stack as my uh, stack is equal to my empty list. Okay. Pop from empty list. Okay. 3 4 5 5 4 3 3 4 5 5 4 3. Okay, so here They have taken data, so I think this should. And so whatever is my current node data, it should be my E dot data, because what is my E? And then we will have current is equal to current dot next. So this is what is given. Suggestion by your own Geeks for Geeks. Okay, so while we are on the right track, but with using a stack to reverse doubly linked list, right? However, this bot has noticed that while we are correctly updating the data of each node, we might be missing an important aspect of doubly linked list. What I said, which one is the next important aspect? Updating the address, right? Updating these arrows. Okay. So what it is suggesting, remember that each node in a doubly linked list has both a next and a previous pointer, right? So every doubly linked list has this next and previous pointer, and we are not taking care of these pointers, right? So that we have to take care. Okay. So after reversing the list, you need to ensure that these pointers are also updated correctly to reflect the new order of the nodes, right? So consider how you might set the previous pointer for each node as you pop from the stack. This will help maintain the integrity of the doubly linked list structure after the reversal. Keep this in mind as you continue to work on your solution, right? So this solution is half correct. Okay, so we haven't updated the pointers, right? We need to update the pointers as well, right? So how do we do that? Okay, how do we do that? So this pointer we have to update, right? We have generally done the solutions. Okay, this is the solution, but this is the halfway correct. This is the half solution only. Okay, half solution. This we have to change. So what do we need to do now? We need to change the pointers. And how do we do that? Okay, so let's think about it. So let us copy this. Okay, now so this is my pointer. Okay, and these values can be different, right? So this is 21, this will be different, right? Okay, this will be 0, 1, 2, 3. Now so there are stars, there are arrows, right? Okay, so these arrows are the basically the pointers, like these are representing the address, right? So this will not be the none. Okay, this will be something. Okay, this will not be none, this will be some address of this. Okay, so this will be some address. Okay, and the last one has to be node. Okay, so this will be node, sorry, this will be none, and this one will be none because after this there is nothing. Okay, and let's say this is 431, so here it will be 431. This is the address which is showing. This is 781, means this is 781. Okay, and this one is 781. This one will be different. This one will be, let's say, 830. So this one will be 830. Okay, because it is pointing in this direction. Okay, this will be 830. It shows the previous one, right? And this one will be 945. This one will be 945. Okay. So this is how the doubly linked list will be, right? So so what to do now? Okay, so I need to take some previous. Okay, I need to take some previous, I need to take some next. um, I think I might need to take some front variable or back variable, right? Likewise, I can think of some strategy to change the uh, this thing. Okay, okay, so let's try to think on those lines. Okay, let's say this is my, so what I have to do is this is 21, I'm sorry, this is 21, let's say this is 24, this is 29, and this is 41. Okay, so what I want is I want this 41 here, then I want 29 here, then I want 24 here, and then in the last 21. Along with that, uh, what I want is, so let me just take one more variable, that is front. Okay, front. So I have this front, then current, then prev, previous. Okay, so these three variables I have. Okay, so I'll start with a while loop. So basically, I'll first be concentrating on while loop first. Okay, so I would say my current variable will be current dot next. Sorry, the front variable will be current dot next, right? So this is for sure, as you can see. So my front variable, this front, it will be this. Okay, just delete it. This will be my front. Okay, so current dot next is front, right? And my, so my front is equal to current dot next. Okay, and my current dot next should be my prev, right? So current dot next can be my prev. So what I'm doing is I'm assigning front to current dot next. Okay, so whatever is my current dot next, okay, this is assigning my front. Okay, now what I'll do, I'll say current dot next is equal to my prev. Okay, previous, because when I'm reversing, the next will become my previous. That is what we want, right? That is what we want. And my current dot prev becomes front. Current dot prev is equal to front. It will come in front, right? And then I'll have prev is equal to current, and current is equal to front. So I will have prev is equal to current, and current is equal to front. Okay, and after that I'll simply return my what? Prev. I'll just return prev. Okay. Apart from this, I need to have some cases where if head is none and all those things, right? So I will just say if head dot next is none, right? Then what I'll do, I'll just return whatever is my head. I'll return that, right? Because it means that whatever is my head, this is none, means there is no next number. So this itself will be my reverse number. Okay, this itself will be my reverse number. Okay, that is the logic. And initially my current will become head here before while loop. Okay, so this will be while. I'll just say current is not a none, so this loop will go on. But here I will have current is equal to head, and what about my previous will be none, right? So my prev is equal to none. I think this code should work. So let us start with current equals head. I will just remove all these. This will be- Okay, so current is equal to head. If head is no, head dot next. If head dot next is none, then what I'll do, I'll simply do I'll simply write what? I'll simply write return head. Okay, I'll simply do return head. Okay. After that, I'll just say current is equal to head and my prev is equal to none. Right. Now, then we will start the loop. Okay. So while current is not none, then what is my front? What is my current dot next? Okay, all those things we will write as it is. Okay. So while current is not none, my front is equal to current dot next. Front is equal to current dot next. After that, what we have written, current dot next is equal to prev. Current dot next is equal to prev. and prev dot next is equal to what? So front is equal to current dot next is equal to prev, and current dot prev is equal to front, and current dot prev is equal to front, right? And then it will become prev equals current and current is equal to front, reverse. Prev is equal to current and current is equal to front. CURR is equal to front. Okay. So these 5 lines of code, I think it should work. I'll simply say current is equal to front, right? Then I'll return ref. I think this run. Okay, so this code is working, right? So guys, this is how we can, solve this problem successfully. We have submitted it and all the test cases are passed.